Come, everybody, gather around. I'm going to tell you a wonderful, magical tale, a tale of two Google employees who set off on a bold journey to create an entirely serverless application on Google Cloud. Some of these events might frighten you, but you're going to learn a lot about Google Cloud and maybe even a little bit about yourself. So first, the dream. So if you've been around this area, you'll see a lot of these experiments. What you may not know is these experiments are also available online. And you can go to showcase.withgoogle.com, and you can launch these apps and mess with them in your own browser. You can also browse the code and download it and launch it yourself. My friend Sandeep, who you may see him around, he's also a cloud Googler. Him and I had an idea to make this app a montage maker. And what a montage maker is it's something that will create a video that's assembled from clips of words from another video that have been reordered to say or show something different. So for instance, if you uploaded a political speech, then you could make, potentially, by rearranging the words said in that video, you could make the politician sing the Pokemon theme song, for example. So let's see what this looks like. We decided to take a couple of videos from DevReller's from Cloud Next 2018 and have them sing
Never.
Rick Astley.
To give you up. Never.
Going
To let you down.
Okay, we can do that one more time.
Never.
going
To give you up. Never.
going
To let you down.
So not exactly a deep fake, but you get the idea. So what this consists of is a backend which will take a video and it will separate it into individual word clips for each word, and a front end that will take a text input and it will assemble that text into videos using the clips that we split from the backend. Now, what makes this serverless? Well, nothing makes this serverless except how we decided to architect it. So we wanted to keep scalability in mind at the forefront, so that it can scale up automatically and it scales down to 0 when we're not using it. We also wanted it to be event-based, so nothing is running until it's spun up by something. And we wanted to have our code broken apart into microservices and also have minimal data at rest. So let's go to a demo. Hi, Google Cloud Next. I really hope this demo works.
Hi, Google.
Cloud Next. I
Really hope
this
demo works.
Okay, good enough. Thank you. All right, so let's talk about how we built it. The front end is pretty straightforward. Not really all that much serverless going on here anyway. We have a front end being served by Firebase hosting, which is a really easy way to deploy a simple HTML app. And in JavaScript, we call a backend basically functioning as an API, which is a cloud function listening on an HTTP trigger. And that cloud function takes a text string and looks and sees if those clips exist in cloud storage. And if they do, it combines them. And if it doesn't, it fills in the missing words with the TextToSpeech API, which is what you saw with the cloud platform logo in the previous demo. So a backend that isn't serverless might look something like this. And this is your code sitting on, say, Compute Engine, a VM, whatever. You give it a video. It uses Video Intelligence API, which can give you the start and end times for every word, and using that information, cut up the video into word clips. But since we want to go serverless, for starters, we decided that we'd use a Cloud Storage bucket to initialize the cloud function. So when you drop a video into a bucket, and it spins up our cloud function. But we can do one better because the video API, Video Intelligence API, can save the results of the start and end time of every word into a JSON file in cloud storage. So now we can make that asynchronous. We're not waiting on our Video Intelligence API to process our video anymore. We just send off the API request, that function dies, and then once the Video Intelligence API is finished processing, a new cloud function is triggered, which then splits the word into clips. So now we have 3 storage buckets on the back end, 1 storage bucket on the front end. And at this point, if you're going, I thought this was supposed to be a happy ending story, you're not alone. So this is pretty complicated. If anyone told you that Cloud Functions is something that you just run your code and you walk away and you don't have to worry about servers or anything else anymore, then they lied. But before we get too discouraged, let me show you what it looks like, because everybody loves a good demo. So here are our cloud storage buckets. I have a video here from my good...
My name is Felipe Hoffa. You're interested in visualizing data. Prepare to rewind.
My good friend Felipe Hoffa, who is also a Googler. So if we architected this correctly, this will have fired off a cloud function. We can verify this by going into our logs viewer here. And it'll take a couple of seconds, but if everything goes well, there we go. This is the logs for our functions, and if you're unfamiliar with cloud functions, you can break down all of their logs right here in Stackdriver to see what they're doing at any given time. So what should have happened is this fired off an API request to the Video Intelligence API, and I am intentionally stalling because I'm hoping when I go into Montage annotations, yep, sweet, the JSON's already there. So this is the transcription data for our video. And you can see it has the correct, mostly correct sentence here, start and end times. And I'm stalling again because I'm hoping by the time I go into here, yep, we have all of our videos.
Rewind. Interested.
Okay, awesome. So just to recap, we use cloud functions for all the glue code. We use cloud storage for storing our data and also for triggering additional functions. We use the Video Intelligence API for identifying words in the video. We use the text-to-speech API for filling in missing words. And PubSub, maybe. Other technologies used just for fun. We use Firebase hosting for serving HTML, Node.js for the function code, FFmpeg for any audio or video manipulation nerds out there. We used Firebase CLI to actually deploy the functions, which is it's a really nice interface. It's a really great way to get started. We used Cloud Source repositories for version control, and Cloud Shell Editor and Cloud Shell for editing the code, running the tests, and deploying. So we were fully integrated into the cloud with this one. So let's talk about the bugs. Then the bugs came. So the first issue we ran into was the Video Intelligence API it's really not that precise. So the precision is 1/10 of a second, which if you're talking as quickly as I am now, or as most people speak in conversation, that's not enough to really get an isolated word. So to get around that, we did a couple of things. We added a second buffer and used a fade in and fade out, which did help. But at the end of the day, we just had to approve each word, which is a horrible process, but it's still better than going through and clipping these words out yourself. And we did this with an admin UI. I'll show this real quickly, just for fun. Probably 1 in every 5 words is good. That's how
Kubernetes.
unprecise this is.
Landscape. Laptop. The launch.
So the longer words are better. Shorter words like the and this and the real common ones, are really difficult to get. Now, these are the more fun issues. So we started by uploading these 5-minute videos, and they got chopped up about as quickly as you saw the demo here. And we thought, this is great. We architected this thing to scale. We're feeling really good about ourselves. Then we tried a 60-minute video. And can anybody guess what went wrong? You saw the architectural diagram. Yeah, we didn't guess either. But this actually seems really, really obvious. So the first thing that happened is we hit maximum execution time. Cloud Function can only run for 9 minutes, and we're having it chop up 60 minutes worth of words. So you remember we have a Cloud Function fire off once the annotations land in cloud storage. How do we fix it? I foreshadowed it. PubSub. Yes, PubSub. PubSub is the hero we needed. PubSub is built for scalability. It's highly available. It's global. It's awesome. So we stuck it right here. We had every single function, every single word spin up a PubSub message to be handled by another function. We added an additional cloud function specifically just to clip the words up. So you're seeing microservices in play, right? We're cutting this application up into the tiniest of pieces. Can anyone tell me what went wrong with this? Maximum number of parallel functions. So a 60-minute video, someone talking, has 10,000 words, maybe. It was something around there, 6,000 words. All being processed at the same time with a function for each of them. So here we got a little greedy. We went too far down the distribution path. And as a result of having too many functions, we then had too many outstanding PubSub messages as well. And then what happens if you have too many outstanding PubSub messages? They get dropped. So we were just having words that were lost. This had a pretty easy solution. We just added batching. So instead of having every single function process 1 word, we had every function spin up and process 10 words. We probably could have gone as far as a couple hundred words, because we initially only had 1 function and it was processing 5 minutes of video. So this is another one of those trade-offs where it will get done faster the more of these cloud functions you spin up, but then you could hit some of these limits. So we immediately hit the CPU quota exceeded because let's say we had 10,000 words. Now we're spinning up close to 1,000 functions a second. And each of them are processing 10 words, which probably takes a minute. So we're hitting this CPU quota. Now, we could get around this by pausing after so many words, only processing so many at a time. What we did was we just requested that our quota got raised, because a lot of these quotas are configurable, and that worked. So that was nice. And I'm really glad we got this error next, because it meant that we got the grand slam of Cloud Functions errors. We hit maximum execution time, maximum number of threads, maximum CPU, and maximum memory. So I guess we're doing something right. Now, a Cloud Function can only be configured for 2 gigabytes of memory, and that is a hard limit. So when we hit this, we knew we had to fix something. Luckily, it was a bug in our code. We had to configure FFmpeg to use streams, so it wasn't operating on an entire 60-minute video. And there was another issue that we had here where we were storing the 60-minute video in a temp file and not cleaning it up. And that was an issue. That's an issue that I'm going to talk about in a second. So some Cloud Functions optimizations out there that you really do need to keep in mind whenever you're using Cloud Functions is each function spins up an instance specific to its function. So you have function A and function B. Function A is going to spin up a function A instance that can handle multiple function A invocations. So in our case, when we had these functions that were processing a 60-minute video, each of them were pulling down a 60-minute video file, storing it in temp, and in Cloud Functions, the file system is memory. So you're filling up your 2 gigabytes of memory, and we weren't cleaning it up, and those files stuck around until the function ran out of memory and crashed. What we did, we could actually use that to our advantage and have every function check and see if the video was already downloaded, and now you skip having to download that video for each function. So you can use the temp directory and the globals in Cloud Functions as a file as a caching system. Another optimization is function size. So if you use Firebase Cli, it's really easy because it just takes an app, a singular app, and it deploys it to every single function. And this is really great to get started, but once your application matures, you're going to want to split each function to its own application so that you don't have a function deploying with another function's dependencies. So in our case, our annotate video function, which all it does is call the Video Intelligence API, it was loading in 300 megabytes of dependencies that were being used in some of the more complex functions that used FFmpeg. So keep that in mind. If you use Firebase CLI, this is an optimization you might want. And the G Cloud, you can also deploy functions with the G Cloud CLI. This is one of the advantages it has. It's a little bit harder to use, but it does give you the ability to deploy individual code bases. So, denouement. Let's resolve this story. Our takeaway was building scalable serverless apps is, I mean, it wasn't terrible, it wasn't great, it's just a very different paradigm and one we weren't used to. So be prepared for that. You have different challenges, you're going to run into some big frustrations. I'm going to go through the cons first because I want to end on a high note. First one we already talked about, simple apps, seemingly simple apps get very complex. If we weren't serverless, this is a pretty good solution for what we wanted on our back end, and it might actually work just as well. And this is what we came up with. This is actually the flow. And this looks insane. If someone was like, hey, here's our app, you're gonna have to debug this, and they hand me a piece of paper that looked like that, I would be like, you guys, you messed this up. This isn't right. Debugging, and as a result, debugging is really hard. So you can watch the logs for function invocations, but at the end of the day, there's no way to see an event go from start to finish easily. And I know we have products like Cloud Trace, and we might be able to integrate that in there. I didn't have time to try that. So it may be possible in the future, but currently there's nothing out of the box that allows you to do this. So you're stuck looking at logs and refreshing storage buckets, which is it's a little more difficult to follow. And another thing is, serverless abstracts away your code from the hardware, and that's true. So you don't have to worry about hardware limitations, but instead you have quota limitations, which can be just as frustrating. So let's talk about some good things, though. The app forced us to think about microservices, and as a result, you get a lot of good things with microservices. For instance, the fact that each function is hermetic, and deploying a new one is quick, and it won't affect any of the other running components of your app. Also, quota exceptions were indicators of flaws in our design every time. With the exception of the CPU quota that we had raised, we were able to get around the quotas by better architecture of our app. And it forces us to think about things that we hadn't previously thought about. Quota increases also, in general, are better than adding hardware, especially if you haven't architected your application to scale with new hardware. If you just build it on a single compute engine instance, you can add another compute engine instance and it's not going to help you at all. Also, there was very little code required in our app. So this entire application had under 300 lines of JavaScript, and that was when I just looked backstage before this talk. I didn't remove white space or comments or logging or any of that stuff. So it's relatively small, easy to maintain. Another really good aspect of this is the cost. So we talked about scaling down to 0. We left the app inactive for several weeks, and the total cost was $0.1 a day, 1 cent a day. Best cent a day I ever spent on tech. And this was just to house the videos that we had in cloud storage. Our most expensive day during development, this is when we were throwing all sorts of videos at it, and we were blowing through quotas, and we had tons of inefficiencies and things that were costing us extra money, was still only $100. And the total cost for the project over 2 months was about $200. So if you were running all of this on a compute engine instance and you really fill that, you made it really beefy so that it could hold all this, it would be about $50 a month, so it'd be pretty cheap. But whenever you're not using it, you're still paying that same price. So it's going to catch up. So was it worth the trouble of serverless? I don't know. I guess that's for you guys to decide. Thank you.